Alright, so let's end our solving radical equations videos by looking at some higher order radicals. Like in this case, we're going to look at a cube root, and we're also going to take a look at some rational exponents, which remember, they also represent radicals. So let's find out what happens. Okay, so starting off with our first problem here, it looks like I have the cube root of 2x plus 7 is equal to 4. And my job is to, again, isolate the radical, which luckily for us, it is already isolated. And then I need to get rid of that radical. And so we have to think about, how do I get rid of a cube root? Well, the opposite of cube rooting is to cube. So if I cube something that is being cube rooted, they will cancel each other out, and I'll just end up with the radicand. But if I cube the left, I need to cube the right-hand side as well. And so in this case, I'm going to get 4 cubed, which is 64. Okay, if I now solve this problem, this is very easy. 2x is equal to 57, which means x is equal to the improper fraction 57 over 2. This is an entirely okay answer. We don't need the decimal equivalents. We'll say 57 over 2. And that's my answer. That's as close as I can get. Okay, go back and check and make sure it is not extraneous, but in this case, we're good. Okay, so on the problem on the right-hand side, if you notice, I now have a 1/3 there, which remember, 1/3 really means the same thing as cube rooting, which means I should be able to do the same thing. So let's try. If I take this entire expression and I cube it, well, let's see what happens. If I raise something to 2 different powers, like 1/3 and 3, I can multiply them together. Well, if I multiply 3 times 1/3, I just get 1. Well, this is 3x minus 4 to the 1. Well, I don't need to write to the first power. So again, they cancel each other out. This and this go away. And this equals 6 to the 3rd power. Right? So I have to do 6 to the 3rd power, which, to the best of my knowledge, is 6 times 6 times 6, which is... let's try that. 36 times 6, 216. So this is 3x minus 4 is equal to 216. Okay, which means that 3x is equal to 220. And again, I get this kind of not really all that nice. Okay, 220 does not divide nicely with 3. And so I'm just going to leave it as 220 over 3, the improper fraction. And that, again, that's entirely okay answer. But this is, again, just take a look at these side by side. One of them I cube rooted with a radical. The other one I raised to the 1/3 power, which means the same thing. And so how I solve these two problems is identical. I cubed both sides because the expressions were isolated, and then I just solved as I normally would. I just made sure that whatever I did on the left, which is cubing, I did on the right-hand side as well. Right, and I ended up with one answer, which in both cases is not really all that nice. Okay, so let's take a look at a couple of more of these rational exponents and see how I handle those. Okay, so again, remember, it's just the same as radicals. Okay, so I'm going to isolate my radical expression, which, remember, this fraction exponent is a radical expression. So I'm going to add the 16 over. This is going to become x to the 1/2 is equal to 16. And then if I want to get rid of the 1/2, remember, 1/2 is just like the square root of x. Right? If I wanted to get rid of this square root, I would square. So let's square. Okay, both sides. Okay, so now this looks like x is equal to 16 squared, which is just 16 times 16 again. Okay, 256, and that would be my answer. That's all I have to do. All right, so let's take a look at this very simple problem and kind of come up with a way, like, how did we handle this? It looks like my exponent that I wanted to go away, which is the 1/2, I multiplied it with its reciprocal. This is really just 2 over 1. And when I multiply something with its reciprocal, the answer is 1, which that's really what I have here. X is x to the 1st power. So I'm going to use that rule in this second one, and we're going to find out what happens. Okay, I'm going to isolate my radical expression, which is the x to the 2/3. Okay, x to the 2/3. When I add over a 70, it looks like I get an 81. Okay, and if I want this x to the 2/3 to go away, I'm going to raise it to the reciprocal, which is 3 over 2. All right, and let's see what happens. Well, 2/3 and 3 over 2, when I multiply those together, that's just 1. Right? It's 6 over 6, which is 1. So that's x. But that means that I need to raise 81 to the 3 over 2 power. Okay, so let's think about what that means. The denominator is like a radical, so I'm going to just turn this into radical form. This is really like the square root of 81. And I'm going to get that answer, and then I'm going to raise it to the 3rd power. So the square root of 81 is 9 to the 3rd power. And so I have to do 9 to the 3rd power, which is 729. So my final answer here is 729. If I plug in 729, raise it to the 2/3 power, and subtract 70, I should expect to get an 11. Okay, so we have this kind of new rule showing up here when we're dealing with solving equations that have rational exponents in them. When I want to solve with rational exponents and I want one of the exponents to go away so that I can get x by itself, it looks like in both of these cases I was able to raise it to the reciprocal of that power that I wanted to go away. And then in the right hand problem I had to do some, okay, well, how do I do 81 to the 3/2 power? And you needed to turn it into a radical and simplify. But the rule itself is still applying. I'm raising it to the reciprocal, and that cancels out, right? You can see here that 2/3 and 3/2 cancel each other out, and I was just left with x as on the left-hand side, and I was able to solve as I normally